Hello everyone, thank you for joining me. Today we will be talking about Swiss machining with GibbsCAM. My name is Andy Heffner, Applications Engineer with GibbsCAM, and I've been with Gibbs for many years and been specializing in MTM and Swiss type machining, so this is what we're going to be talking today about. Feel of course free to ask questions. You may ask your questions by typing them into the Q&A panel while we are at the presentation. Then if questions we cannot answer during the live session, we will be answering them after the webinar. And the session also will be recorded. What are Swiss type machines? Swiss type machines, they are also called sliding headstock machines. They originated actually in Switzerland to make parts for the watch industry, hence the name Swiss type machines or Swiss machines. Let's look at some Swiss machines. Let's see what we have here. All right, jumping right into it. Okay, here we have a Swiss style machine with the sliding headstock and the guide bushing on the right hand side. Our sub spindle is on the left. We have, of course, the gang with our turning tools on top, some milling tools on the top as well. Then this machine has a B-axis with tools that can access the main spindle, and on the other side you can access the sub spindle for B-axis machining angular features on the part. And then we have another set of tools, four back turning tools. The upper ones are live, the lower ones are stationary, and then we have a parts catcher where we drop off the part once we're done. All right, let's run the part and see what's going on so you have a little bit of an idea what we're going to be talking about. Okay, so we are machining on the sub spindle with our B-axis right away, putting some angular features on it. Then the sub spindle goes over, machines the back side of the part on the fixed post, and the main spindle tools the gangs machine on the guide bushing with the sliding headstock. Let's continue on. Let's watch the part running through. Here we're machining actually the backside, or actually with the backside with the sub spindle tools over on the main spindle, doing some drilling, then more machining on the main spindle, grooving, more grooving, and once we're all done, we do some B-axis machining on the main spindle as well, putting some nice little chamfers there, and then we continue on, machining our part, more grooves. This is a valves piston, so this is what lots of grooves on there. Now the sub spindle came in and is picking up the part. We're doing cut off, and the sub spindle returns to home. Okay, we're going to look at it again, but I want to show you first one other thing here that's actually usually where we select our machine. This is what we call our DCD, Document Control Dialog. Here we select the machine, whichever model it may be, or that we have on our shop floor that we want to program. The material that we machining, the size of the material, facing allowance, how long the part is, stock size, the gap between the tools and the guide bushing. Those numbers are grayed out because they are fixed depending on what guide bushings you're using, and this number, this length here is quite important. This is the length of the guide bushing. The length basically how long our part is being supported when we being pulling back inside the sub spindle. That happens of course on the Swiss machine. And then a couple of other things, outer clearance, stock approach and retract, and then some more on the sub-spindle side, the stick out length, how far our part is being sticking out after we did cut it off. This is pretty much it. We are an inch or millimeters, depending really on our part, which way we want to program. It doesn't really matter. We can do both. I want to close this again, and then I want to show you something that's quite important for Swiss style machines. I'm going to wrap it. First I rewind, of course. Let's do a rewind, and then look at it again, just like this, and I wrap it a little bit to a spot where I want to stop it, and we're right there, where I want to show you something that's rather important on a Swiss style machine. So Swiss style machines, the stock is moving in and out, and that in and out of the guide bushing, the red part here. So it happens once we start machining the part on the front. I'm slowing it down a little bit. As you can see, we're machining the diameter, and when we pull up and we machine again, and we pull back the stock into the guide bushing. And this is something that we have to be very careful with, because we may have left a burr on the outside diameter with our first cut, and when we pull back into the guide bushing, we may actually damage the guide bushing because with that burr that's sticking out. So if I keep going, I want to show you what we have in GibbsCAM that really lets us take a nice chamfer on that outside edge that we have machined. So when we pull back into the guide bushing, we are not sticking out that burr. Okay, this is our operation. This is our roughing toolpath, and what we have here is what we call chamfer bar. When I check this, I can set the length of the chamfer that I want to put on top of that, and then which way do I want to machine it? Want to machine it forward or backward? I personally prefer the backward motion. So let's do this, and I do a redo, and now we have a nice, a nice chamfer on our outside diameter. So when we pull back in our guide bush, we are nice and protected. We don't damage our guide bushing anymore. Okay, let's go back again, rewind, speed through it real quick, and slow it down again. And what you will see here now, it's going to pull back and put that nice little chamfer on that outside diameter. We see this on that side a little bit better, and we can continue on machining this part. So it's a nice feature that is very important actually for Swiss style machines. Any type of Swiss machines, doesn't matter really. For any feed, any Swiss machines, we have that same feature. Even, believe it or not, on fixed Headstock, we can actually program it that way. Okay, so we can real quick look at our sync manager, and then we're going to move on to another part. Sub-spindle comes in, we cut off the part, and we're done. Sync control manager. This is basically what we have for all our MTM machines, Swiss machines. So what we see here are all of our operations from top to bottom. This is the one we just had modified. We have the main spindle gang and then the sub-spindle gang and tools that work for the sub-spindle. And here we have our Swiss machine modes that we have to program certain machines to put the machines in a certain mode that it requires for do this, that, and something else. Okay, let's move on. I want to show you another machine. It's very similar, and the part is also very similar. Not quite exactly the same, but This one was the sliding headstock version where we had the bar stock being pushed in and out of the guide bushing. Now we're switching to a machine that's the same machine, but it has been modified to be a chucker. Okay. When I say it's a chucker, it is. Let me move this around. Hold on. There we go. So what you see now, it's the guide bushing is not there anymore. Basically, that piece is basically our headstock, but it's moving out, and we stick out our part as we would be on a normal fixed headstock machine, machining the part. I run this real quick, and then we're going to see what's going on the main spindle side. I move it around a little bit. Let's do this. Yep. Okay, there we go. Now, see that? Okay, now we are machining, and our headstock is basically, our part is being fixed and clamped in the headstock, and the whole headstock is moving, and that we call it being a chucker. So it's the same machine, but it can be modified from sliding headstock to a chucker type machine. Okay. Similar parts, similar features, some machining OD, ID, things like that, and we are done. We pick the part up. The quick difference on this one is in our DCD, in the document control dialog, and here we don't have the symbol and design of our guide bush anymore. This is now basically just our length, stick out length of the part. Again, our part stock, my facing allowance, and whatever length of the part, or actually sticking inside the guide bush, the headstock. Okay, so this is the difference between sliding headstock and chucker documentation dialog. Okay, let's move on to another machine. This was part, okay, now let's switch to this one. A very common thing on Swiss type machines are being bone screws. This is one of those bone screws. It has quite some nice features on it, and we're gonna be using that with our thread whirling heads. So what you can see here, we have a coarse thread going halfway through the part, and then we have some fine threads, but different shapes. The first two are different than the next two. So you can see that when we machine it, there is different shapes of the thread, and I can actually show you this real quick in our form tools that we're using on our thread whirling head. This is the white one for the front part of it. This one is more an edgy type of the thread, and this is more the round type. So those are different shapes actually on the ball screw, not the ball screw, the bone screw on that part. Okay, with all that said, let's look at the machine. So this one is a little bit a different configuration. Of course, again, we have a gang, some live tools. Even this one has a B-axis on that side, and with tools on the back side for the subspindle, and then we have our turret with our 3 thread whirling heads to whirl those 3 different shapes on the thread on the bone screw. Okay, let's go ahead and start machining. So we're machining over on the main spindle, turning the OD. Now we come in and do some drilling. It's quite a deep hole there, going all the way through the bone screw. And after that, we're gonna come up with our sliding headstock. Nope, with our thread whirling head, I'm sorry. Okay, and we are just about there, and I want to zoom in a little bit so you can see a little better what's going on. So this is the insert for our white thread, and we're gonna do it twice because it has two starts. So a little bit more. This is the first start, pull back out, and this is the second start. All right, so this is our whirling head for the coarse part of the thread and the bone screw. Okay, now we're gonna do a little bit some drilling. Okay, a little bit more turning, and I'm gonna slow it down again. Okay, and then we come with our other thread whirling heads and do the finer shapes of the bone screw. Of course, we have to pull back into the guide bushing, make room for the thread whirling head to come up without hitting. So this is the next one. So the trick here is actually really to find the end of the coarse thread. We're pulling out again. This one goes away and then brings up the other one, the final one. Come on, there we go. And this is a different shape. Again, the trick is to match perfectly the previous threads being machined with our whirling heads. And then we finish, of course, the part machining the head and the back. And then we come in with our sub spindle. Let me move it around and pick up the part, cut it off, and we're done. Okay, there comes the sub spindle, cut off, and sub spindle goes home. That was this. Now let's look at another part or another machine. Actually, it doesn't matter so much the part, but this is something quite unique as well. It's not necessarily a sliding headstock machine or a Swiss type machine, but this machine has a feature that GibbsCAM uses. GibbsCAM NTM is very well suited to program this kind of machine. And I'm going to run the part and you will be amazed what you see. What you see, left side is the main spindle, right side is the sub spindle, and we have a turret. It's a relatively simplified simulation, which actually in this case I really prefer, since we need to see what's going on in our simulation and potential collision of the part and the tools. Okay, let's run it. And what you will see in a second is that the sub spindle is basically chasing the tool that's sitting on the turret. That actually the turret is moving, machining the part on the main spindle, while the sub spindle is chasing the other tool around while it's machining on the front and the main spindle. It's quite a complex way of programming these kind of machines, and typically I know that operators and programmers are pretty scared to program these kind of machines, but what we do in GibbsCAM, we give you the tools to program that type of machine easy and without, of course, collision. That's, of course, the important part. And whatever the machine modes these type of machines need to let you safely program these type machines is, of course, key for having using the right programming system in this GibbsCAM. Of course, GibbsCAM gives you all the tools that you need, even for this type of machines. Okay, where are we? This is pretty much what I wanted to show you on the Swiss type machines, how we program them or what's available. Of course, I could go more into many more details, but they would actually then end up in a training session, not so much an overview of the general kind of Swiss type programming that machine that you can do with GibbsCAM. Okay, with that said, I want to open it up for questions.